Children, it is a continuation of the chapter electricity. Here there are some questions in your textbook that is in relation with the combination of the resistance, that is the connection of resistance in parallel and series. So here let us solve one by one. First you take the first question, that is judge the equivalent resistance when the following are connected in parallel. The first one is 1 ohm and 10 to the power of 6 ohm, and second B 1 ohm, 10 to the power of 3 ohm and 10 to the power of 6 ohm. So first let us take A. Here two resistors are there. First one is R1, that is 1 ohm, and R2 is of 10 to the power of 6 ohm. Now here the connection is in parallel, means we have to take 1 by Rp. Here we have to find out Rp, that we have to judge here. So you take 1 by Rp is equals to 1 by R1 plus 1 by R2. Then it is equals to 1 by R1 means 1 by 1 plus 1 by R2 means 1 by 10 to the power of 6 it is, and the LCM here is 10 to the power of 6. So the numerator becomes 10 to the power of 6 plus 1 it is, and 10 to the power of 6 means we have to take 1 and 6 0. It becomes 10 lakh plus 1 by 10 lakh. And here it becomes 1 by Rp is equals to, that is 1 lakh by the sum of these two is that you have to take plus 1. So it becomes 1 by what? 1 lakh, 10 lakh 1 by 10 lakh it is. So if you take Rp, it becomes 10 lakh by 10 lakh 1. So you know that it is because here the numerator is less than the denominator, so it is less than 1. Less than 1 ohm it is. Less than 1 ohm. The resistance in the first case is less than 1 ohm. So here what you can judge, the equivalent resistance is less than 1 ohm in the first case A. And next you take the second one, B. Here what is that? B is 1 ohm and 10 to the power of 3 ohm and 10 to the power of 6 ohm. So let us take R1 is equals to 1 ohm and R2 is equals to 10 to the power of 3 ohm. R3 is equals to 10 to the power of 6 ohm it is. Now again here the connection is parallel connection, so you have 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Then it is 1 by 1 plus 1 by 10 to the power of 6 plus 1 by 10 to the power of 3 plus 1 by 10 to the power of 6 it is. 1 by 10 to the power of 3 plus 1 by 10 to the power of 6. And the LCM becomes here, LCM is 10 to the power of 6 it is. So here the numerator becomes, first case here 1 into 10 to the power of 6, 1 into 10 to the power of 6, that is 10 to the power of 6, plus here 10 to the power of 3 into 10 to the power of 3 is 10 to the power of 6, so it is 10 to the power of 3 plus 1 it is. So it becomes you know that it is 10 lakh and it is 1000 plus 1 by 10 lakh by 10 lakh, and it becomes Know that the sum one becomes, so it is 1001001, 10 lakh 1001 it is by 10 lakh. It is 1 by Rp, that is equals to 10 lakh 1001 by 10 lakh, and here therefore this implies Rp is equals to 10 lakh by 1, it is, that is 10 lakh 1001. So you know that here numerator is lesser than the denominator, so it must be less than 1 ohm. So in both the cases you got the equivalent resistance less than 1 ohm. So in this way you can choose the equivalent resistance. Now let us take the second question, that is an electric lamp of 100 ohm, a toaster of resistance of 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220V source. What is the resistance of electric iron connected to the same source that takes as much current as all three appliances, and what is the current through it? Here there are three electric appliances. First one is electric lamp of 100 ohm. So let us have R1 is equals to 100 ohm here. And second, toaster of resistance 50 ohm. So the second device is toaster of resistance 50 ohm. So its resistance is R2. So that is 50 ohm here. Next, water filter of resistance 500 ohm. So let us write this is R3, that is equals to 500 ohm. Next, all these are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much current as all three appliances, and what is the current through it? Here you know that the resistance of the electric iron box is equals to the equivalent resistance of these three appliances which are connected in parallel. So you can take that here. Let us have Rp. Rp is the equivalent resistance, and that is equals to the resistance of electric iron box. Resistance of electric iron that is equivalent of R1, R2 and R3 which are connected in parallel. So if you find the equivalent resistance of this R1, R2 and R3, that becomes the resistance of the electric iron box. So you take here, first you find the equivalent resistance. You know the relation, that is 1 by Rp. As it is a parallel connection, you must have 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3 it is. 1 by R1 plus 1 by R2 plus 1 by R3. Then 1 by R1 is here 100 ohm. So you write 100 plus 1 by R2 is 1 by 50 plus 1 by 500. And the LCM of these three must be 500 here. So you write LCM of 100, 50 and 500. You know it is 500 only. So 100 into 5 is 100 means 1 into 5 is 5 here. Plus 50 into 10 is 500 means that is 1 into 10, that is 10. Plus 500 into 1 is 500 and 1 into 1. 5 into 1 is 1 here. Then that is 1 by Rp is equals to, you got here. So 1 by Rp is equals to, that is the sum of this is 16 by 500. Then therefore you will get Rp is equals to 500 by 16 it is. Rp is equals to 500 by 16. If you divide 500 by 16, you will get 16 3s are 48. 2 is remaining here. So 16 1s are 16. 4 is remaining. So you put 0. Point you put. 16 2s are 32. 8 is remaining here. And you know that 16 5s are 80 here. So it becomes 31.25 ohms it is. 31.25 ohms. It is the resistance of electric iron. Therefore, resistance of electric iron is equals to, that is 31.25. So here voltage, applied voltage is 220. So current we have to find out. Take V is equals to 220 volt and R is 31.25. What have to find out here? I we have to find out. Current, you write the relation among these according to the Ohm's law. You can write I is equals to V by R. I is equals to V by R. V is 220 volt and R is 31.25. So here remove the decimal point here, that is 3125. Take extra 20 to 2000 here, and here you will get approximately, it is, you know that if you divide it 31 3 sevens are 21 you will get, that is 7 point you will get here. Here try to divide it. We know that it is divisible by 5. 5 6 and 1 2, that is 5 2s 5 5s. Here it is 5 4s 20, 5 4s 20, 0 0. Again it is divisible by 25. Then you can divide it by 25. 25 25 the 25 1s 19 is remaining, 190. So you will take here 7s 7s means again here you will get 15 means 150, that is 25 6 150. So you will get 176 by 25. So if you divide 176 by 25, you will get 25 sevens are 175 and 1 is remaining. Put 0 point here. Again it is not divisible. Put 0. So it becomes 7.04. That is equals to 7.04 amps of current will pass through it. So what is the current through it? Current through it is 7.04 amperes. Third question, what are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? We know the disadvantages of series connection. If the appliances are connected in series in the circuit, if there is any damage in the appliances, the other appliances also will not get current and they will not work, one thing. And the other thing, you know that here all the devices gets the same current, and you know that here some electrical appliances need more current, some electrical appliances need less current. So it is one of the disadvantages in the case of the connecting the electrical appliances in series. But here the question is, what are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? And if you connected the devices in parallel, each device gets the full battery voltage, and the parallel circuit divides the current through the electrical device. Each device gets proper current which is required, that is depending upon its resistance. And third one, if there is any fault in the device, or if the switch is off on from the one device, others will not affect here, they will work themselves. These are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series. So you write the advantages of connecting electrical devices in parallel with the battery are as follows here. The advantages of connecting electrical devices in parallel with the battery instead of connecting in series, you write. So first one is, each device gets the full battery voltage. In the case of parallel connection, there is no change in the voltage from device to device. All devices gets full battery voltage, that is in equal quantity. Next, second, the parallel circuit divides the current through the electrical devices. The parallel circuit divides the current through the electrical devices. Each device gets proper current depending on its resistance. Next, third one is, if one device is switched off or on or damaged, Others are not affected here. Others are not affected. They will work themselves. Here there is no any problem. If any device is having problem, the other devices will not affect from the problem of the damaged device or switched off device. These are the advantages of connecting electrical devices in parallel. Then the next question, how can three resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm and 1 ohm? Here, to get the 4 ohm, to obtain the total resistance of 4 ohm, by connecting the 2 ohm resistance in series, that becomes 2 ohm with the parallel combination of 3 ohm and 6 ohm. Here you know that 1 by 3 plus 1 by 6. 1 by 3 plus 1 by 6 means the LCM becomes 6 and the numerator becomes 2 plus 1 and result you will get 3 by 6 and the resistance becomes 6 by 3. 2 you are going to get and this 2 and the parallel result here. Parallel connection result is here 3 ohm 6 ohm parallel connection result is you will get 2 ohm. So 2 ohm plus 2 ohm becomes here it is 4 ohm. So here what happens, you must connect R1 series and R2 and R3 in parallel here. Here R3 and R2 and R3 parallel and this is connected with series like this way. These two must be connected like this way and next one here it is R1, R1, R2, R3. So then what you will get, that is first 1 by R1 plus 1 by R2, that you have to find out. That is 1 by R1, not 1 by R1, that is 1 by R2 plus 1 by R3, that is 1 by RP it becomes. So you will have 1 by 3 plus 1 by 6, that is the LCM is 6, you will get 3 2s means 2 plus 1, that is 3 by 6, 3 1s are 3 2s are. So 1 by RP is equals to 1 by 2 implies RP is equals to 2 ohm here. So you got 2 ohm by connecting 3 ohm and 6 ohm in parallel and again by connecting the 2 ohm resistance with this 2 ohm, that becomes total 2 plus 2. Then here it is this RP, R1 and RP are connected in series. Then it becomes equivalent resistance is equals to, that is series here, R1 plus RP, that becomes 2 plus 2 is equals to 4 ohm. So what you can write here, the answer is by connecting we can obtain total resistance of, we can obtain total resistance of total resistance of 4 ohm by connecting the 2 ohm resistance in series with the 2 2 ohm resistors in series with the parallel combination of 3 ohm and 6 ohm. Here to get 4 ohm, you must have the parallel connection of 3 ohm and 6 ohm. Together with that connection, you must have the 2 ohm in series connection. In this way, you will get 4 ohm. Second one, to have 1 ohm. To have 1 ohm, you know that here it is 2 ohm, 3 ohm, 6 ohm means you can have 1 by 2 plus 1 by 3 plus 1 by 6. What you are going to have here? 1 by 2 plus 1 by 3 plus 1 by 6. Here LCM is 6. So 2 3s are 6 means it becomes 3. 3 2s are means 2 plus 1. So you will get 6 by 6 1. So what you can do here? Here you can, by connecting all 3 resistance in parallel, you will get 1 ohm. So take here B. Here 1 by R1 plus 1 by R2 plus 1 by R3, that is equals to 1 by 2 plus 1 by 3 plus 1 by 6 is equals to, the LCM is 6 here. 2 3 is 6, 1 3 is 3, 3 2 is 6, 1 2 is 2 plus 1 6 1 is 6, 1 1 is 6, 1 1 is 1, that is equals to 3 plus 2 plus 1 is 6. It's equals to 6 by 6 is equals to 1. So here 1 you will get by connecting all the 3 resistance in parallel. So to get 1 ohm, what you have to do? You must connect all the 3 resistances in parallel. So we can obtain a total resistance of 1 ohm by connecting resistances of 2 ohm, 3 ohm and 6 ohm in parallel. Next, let us have the fifth question. What is the highest P? What is the lowest total resistance that can be secured by connecting by the combination of 4 coils of resistance 4 ohm, 8 ohm, 12 ohm, 24 ohm. Here we have to find out the highest resistance getting and lowest resistance getting by connecting the 4 resistances, that is 4 coils of different resistances 4 ohm, 8 ohm, 12 ohm and 24 ohm. Now you know that by connecting all them in series, all the resistances adds up, so there is a chance of getting highest resistance. And by connecting all the resistances in parallel combination, you will get the lowest total resistance. So to get the highest total resistance, connect the resistances in series here. So you take to get the you take A to obtain highest resistance, or highest resistance can be obtained by connecting the 4 coils 4 coils in series. Then RS becomes 4 plus 8 plus 12 plus 24, that is 12 plus 12, 24 plus 24, 48 ohms you will get. Next, to have the lowest resistance, all the 4 coils must be connected in parallel. So you write lowest resistance can be obtained by connecting the four coils in parallel. Then here it becomes 1 by Rp is equals to 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. Here the LCM is 24, and you know that 4 6 is 1 6 is 6, and 8 3 is 1 3 is 3, 12 2 is 1 2 is 2, plus 24 1 is, it becomes, you know that 6 plus 3 9, 9 plus 3 12, 12 by 24 you will get. So 1 by Rp is equals to, that you will get here 12 1s are 12 2s are 1 by 2 you will get 1 by 2. 1 by Rp is equals to 1 by 2. Therefore Rp is equals to 2 ohm. That is the lowest resistance you got here. In this way, by connecting in series you will get maximum resistance. By connecting in parallel you will get lowest resistance. That is the minimum resistance here.